Hi guys, welcome back. Today we are going to learn to calculate with compound measures. We've got 4 success criteria, and the first one is to be able to convert compound units of measure. So how do we convert from centimetres squared to metres squared? Well, if we take a look at this rectangle underneath, and the area of the rectangle will be 1000 centimetres squared. Now to go from centimetres to metres, we divide by 1,000. Divide by 100. So a lot of people make the mistake of simply dividing the area by 100 to convert it into metres squared. But we can't do that. We need to divide each of the lengths by 100 to convert each length into metres. Then if we multiply those together to get the area in metres squared, you can see the area is 0.1 metres squared. So to go from centimetres squared to metres squared, we need to divide by 100 squared. So if we want to convert 4 metres squared into centimetres squared, well, to go from metres to centimetres, we'd times by 100. So to go from metres squared to centimetres squared, we need to times by 100 squared. Which would be 40,000 centimetres squared. To convert 700,000 metres cubed into kilometres cubed, to go from metres to kilometres, we divide by 1,000. So to go from metres cubed to kilometres cubed, we need to divide by 1,000 cubed, which would be this. This time we're going to convert 900 millimetres cubed into centimetres cubed. So to go from millimetres to centimetres, we divide by 10. So to go from millimetres cubed to centimetres cubed, we need to divide by 10 cubed, which would be 0.9 centimetres cubed. So for a length scale factor, we simply just times by that scale factor. If it's area, we need to times by the length scale factor squared. And if it's volume, we need to times by the length scale factor cubed. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers. There's your amber answers. And there's your red answers. So now we've completed success criteria 1. So now we're going to move on to number 2, and this is to calculate density, mass and volume. So density is the measure of the weight of an object in relation to its size. Mass is the measure of the weight of an object. And volume is the measure of space inside a 3D shape. So what can we use to work out density, mass, volume? or we can use a formula triangle that looks like this. It has density, mass, and volume on it. To work out density, we do mass divided by volume, and to work out volume, we do mass divided by density. To work out mass, we do density times volume. So this question says find the mass of a stone which has a volume of 40 centimeters cubed and a density of 2.25 grams per cubic centimeter. So we want to find mass, so we cover up M for mass, and that tells us to do density times volume. So we do 2.25 times by 40. So the mass is 90 grams. We know it's going to be in grams because the density is in grams per cubic centimeter. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So in this question, we want to find the density of the metal. So we use our formula triangle, and we cover up D for density. And that tells us to do mass divided by volume. So the mass is 32 grams and the volume is 4 centimeters cubed. So the density is 8 grams per cubic centimeter. In this example, a cubic meter of concrete has a density of 2.4 grams per cubic centimeter. What is the mass of the concrete in grams? So we want to work out mass, so we do density times volume. So the density is 2.4 grams per cubic centimeter, and a cubic meter of concrete means that each side has a length of 1 meter, so that volume will be 1 meter cubed. Now we need to make sure that that's in centimeters cubed. So we convert meters into centimeters by timesing by 100. So we convert cubic meters into cubic centimeters by timesing by 100 cubed. So the mass will be 2,400,000 grams. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers. There's your amber answers. And there's your red answers. And now we've completed success criteria 2. So now we're going to move on to number 3, and this is to calculate pressure, force and area. So pressure is the measure of the force exerted on an object relative to the surface area on which the force is applied. Force is an influence exerted on an object tending to change its motion or induce stress on a stationary object. An area is the measure of space inside a 2D shape. So what can we use to find pressure, force, area? Well, we can use another formula triangle with P for pressure, F for force, and A for area. So we find pressure by doing force divided by area, and we can do area by doing force divided by pressure. We can find force by timesing pressure and area together. So in this question, a force of 45 newtons is applied to an area of 26,000 cubic centimetres squared. Work out the pressure in terms of newtons per centimetre squared. So we want to work out pressure, so we cover up P for pressure, and we do force divided by area. So we do the force, 45, divided by 26,000, which is 0.00173, and that's newtons per centimetre squared. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So in this question, we want to work out force. So we cover up F for force, and we do pressure times area. So we do 300, and we've got to make sure the units are the same. So our area needs to be in meters squared, which it is. So force is 6 newtons. In this question, a force of 185.6 newtons is being applied to a square of side length 0.2 meters. Work out the pressure on the square in newtons per centimetre squared to 3 significant figures. So we want to work out pressure, so we cover up P for pressure, and pressure is force divided by area. So the pressure is 185.6 newtons, and the area of the square, and remember we want this in centimetres squared, so 0.2 meters is 20 centimetres, and because it's a square we know all the sides are going to be the same, so the area of the square is 20 times 20. So the pressure will be 0.464 newtons per centimetre squared. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So in this question, we want to work out area, so we cover up A for area, and that's force divided by pressure. So the force is 735 newtons, and the pressure is 25,000 newtons per metre squared. So that tells us our area is going to be in meters squared. So that's 0.0294 meters squared, which we now need to convert to centimetres squared. So to go from meters to centimetres, we times by 100. So to go from meters squared to centimetres squared, we need to times by 100 squared. So that's 294 centimetres squared. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers. There's your amber answers. And there's your red answers. And now we've completed success criteria 3. So now we're going to move on to number 4, and it's to apply to problem solving questions. "200 grams of aluminium and 1 kilogram of copper are mixed to make an alloy. Aluminium has a density of 2.7 grams per centimeter cubed, and copper has a density of 8.9 grams per centimeter cubed. Work out the density of the alloy." So let's write down what we know first of all to be able to answer this question. Now the common mistake here is people just add together both the density of the aluminium and the copper together to get the density of the alloy, but we cannot just add together compound measures. Instead, we've got to find the volume of aluminium and the volume of copper. So we know for mass, 1 kilogram is 1,000 grams. So the mass of the alloy is 1,200 grams. The volume of the aluminium would be 74.074, and the volume of the copper would be 112.3596. So that means the volume of the alloy, we add both of those together, will be 186.43362. So now we can work out the density of the alloy. Now density is mass divided by volume. So the density of the alloy is 6.437 grams per centimeter cubed. Here are 2 questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So for the green question, let's write down what we know. So we want to work out the density of the alloy. We know it's got a mass of 285 grams because we can add together the mass of the copper and the mass of the zinc. Then we work out the volume of copper, which is 20, and the volume of zinc, which is 15. So the volume of the alloy will be those two added together, which is 35. So then we can work out the density of the alloy by doing mass divided by volume, which is 8.14 grams per centimeter cubed. For the red question, we write down what we know. Well, we've got the force, and we've got the pressure. So the area will be 0.0144, that's meters squared. To get it into centimeters squared, we need to times by 100 squared. So that's 144 centimeters squared. And the volume of the pyramid is a third times the base times the height. So we know the base is 144 and we're told it has a height of 15 centimetres. So the volume of the pyramid is 720 centimetres cubed. And now we've completed success criteria 4. So now that we've completed the last objective, it's time to end the video. Hope you enjoyed it and hope you found it useful. Make sure to like and subscribe, and be sure to check out the videos on the rest of the channel. I'll see you next time. See ya.